Hello, hello. I hope you're all doing well. I'm Dennis, one of STEAG'S many engineers, and I'm so happy that finally we can have our next webinar together. I'm very happy to see an international group of attendees here, some friends, some former professors from university, some partners, some customers. It's great to see you all, and it would be great if I could see you in half an hour in the breakout room. I put already the link in the chat box here for all of you. So before we get started, allow me 10 seconds for the housekeeping. I even shortened that down even more compared to last time. Just a second. Just to let you know, you can see me, I can see your names, but nobody sees your camera. If we later go to the breakout room, you can choose to turn your camera on and so on. So it's absolutely confidential here, your participation, and I will not name any names or I will not name any customers in specific terms. So if you have questions, you can always put them here for me in the chat box. I will try to keep an eye on that. I hope you can hear me well. If not, please let me know. And I hope you also like the new format. We tried to speed it up a little bit, so only half an hour of webinar today, and then the discussion opportunity. So let's go directly into the topic here. And today is a very special attempt there to not talk about software, not to talk about systems, talk about engineering, talk about projects, talk about experience. And I would like to take you on a ride with my colleague, Dr. Florian Dauber. He is responsible for many things, but also for wind and PV projects there. And we will look how that feels for him to be in the office, to figure out what's wrong. And I will try to use that as an example for all of us here to really see where the issues are there in the daily business. So yeah, in the shoes of an operator, that is really the guiding principle for today. And so individual solutions for service, maintenance, and spare parts management of assets in the energy sector. You see, it's pretty broad. You will see PV, wind, conventional power plants, all of that in a quick ride here. So if you have questions, I will be happy to address them at the end, as I said. And now let's go right into the example here in the shoes of Florian. So that's my colleague, Dr. Florian Dauber. He's here as a project manager. He was here with me in the past. You can go to our recordings and you can look. We talked about Epsilon. We talked about a quarter solution where we optimize the energy flow there. That is available in our media library, which I linked for you already there. So let us look how that feels for him. He's in our headquarters here with our colleague Christian, and they are both looking here at data from a wind farm that STEAG owns and operates. On the left-hand side, there's a screen showing us a heat map. We will see that in more detail a little bit later, but it's maybe 50 or 80 measurements that are on this screen and maybe 2 years of data on the left screen. On the right screen, they already chose one value that has an anomaly. That is an important term because it's not an alarm. It's nothing like wrong and they have to immediately go out there. Let me quickly check it here. Oof. So there's nothing super wrong, but something is not right. So that is not good. And they have to decide what they do with that information. So of course, if that one KPI is on the screen, they are able to go into more detail, see exactly when the problem started, see exactly when it occurs. Is it with high wind speeds or low wind speeds and so on? That is all available for them here. But they have to make a decision. They have to decide, should we do something or not? And I think that is something pretty representative for many of you here attending, for many around the globe. You are there, you have the data. If you have the data and you have to make a decision. Why am I saying it like that? Since it's not a power plant with a high-speed internet connection. We talk about maybe a wind turbine somewhere on a field, maybe a little bit outside on the coastline. So let us all remember how it is on vacation if your internet is not so strong. What data do you have sitting here as Florian and Christian? And is it like minute mean values? Is it second values? Is it 10-minute mean values, 15-minute values? Is that reliable and so on? So that is actually the challenge here. And in this case, I think it's like 10 or 15-minute mean values. So it's pretty difficult already to see if something is happening. So in this case, the two decide to go there on site to really figure out what's wrong. They take one of STEAG'S electrical cars and they just go for a ride. There's no traffic here since I cut that out for the sake of time. But you see, you go somewhere, it takes a while. It's getting greener here. That's not so far from our headquarters, half an hour if you're lucky with the traffic. But what we see here, if you do not have the right tools with you, if you don't have your climbing equipment with you, if you don't have your interfacing card, whatever you need, you're pretty much lost. And the whole trip was the waste of time. And that could be your time, but it could also be a service provider that you asked to do something for you and you have to pay for that. So they arrive, they want to go in, so safety first, of course. And now on site, they have many advantages. They can smell if something is strange. They can look at additional screens. They can see data that they don't have in the office. So that is pretty helpful to really get a deeper feeling there of what is wrong. Let's say they are able to solve the problem. They have all the tools with them. If not, it's really bad because you cannot make the trip twice in a day. And if it's even outside further away, that's impossible. So that's what we have to keep in mind there. And if they are done, they can go to their next job or even back to the office. And that was more or less the trip, but that should be the guideline here. In the shoes of an operator, what they need to decide if something needs to be done or not. And also we will see a little bit later what that means if you can really keep that data to have like a service record, because I'm sure that will increase the value if you want to sell your asset a little bit later, 10 years later, 15 years later. Whenever you want to sell it, it's very valuable to prove that you've done everything that you can and it's in a good condition. So this little example here should answer a couple of questions here. So first of all, it is crucial to have an overview of multiple assets at the same time. As we saw, they had one screen with many assets. If they need to click on every single one of them one by one, that will take a lot of time, which is worthless, doesn't make any sense. So do I have the remote access to the data? I put that question there before. Do I see the data, or is it just somewhere in the SCADA locally and I cannot access it at all? Second, do I use a dozen or even more manufacturers' platforms on a daily basis? Of course, they all come with a nice web interface, but do you really want to go there? Do you really want to pull them up one by one, or do you need one view where everything is on a screen? What needs to be checked on site, because you will not be able to solve everything just from the office. At some point, somebody has to go there, and hopefully they have the right information and the right tools with them. And who can do that? Are any special tools or qualifications required? You don't need to send somebody who cannot go up there and fix it or doesn't have the right tools with them. So that is really the challenge. Good. So now that we are even more people here, I would like to quickly ask you two questions just to learn a little bit more about you. That is also confidential. I will not show any names here to anybody. If you like to, it would be great if you would just click on the industry that is most reflective to you, just to see where everybody's from. Oh, I already can see a couple of answers here. Education, thermal coal. Oh, that's pretty much distributed. Thermal other. What else? Waste to energy. Great. Let's keep it quick here. Let's give it 5 more seconds. Thank you all for voting here. And I will present the results right now. Looks like a peace sign, which is a good sign for current situation in the world. So we have a pretty nice distribution here. So I think this example then will give everybody the chance to learn something, and we are not focusing just on one thing, not even just on the renewable, for everything. We will look more of what the practical outcomes are there. So if you allow, I would like to ask one more question. That is your motivation here. Just to see a little bit more what we should put the focus on. Are you more of an owner operator? Do you provide a service to somebody? Are you an investor or just interested? And as I said, it's just, it should be interactive here. I would like to chat with you. We can chat in half an hour or just 20 minutes remaining. Also here we have a nice distribution. Let's give it another 5 seconds. Great. Okay, so present the results. See, most people are just interested, and we have an operator here and as well consultant. I'm not sure if it works for everybody, the whole voting system here, but it's giving us a nice feedback loop. And now let's just jump into the next slide deck to look at more what is behind and what the solution is for those problems that we just had a look at. So, to understand better what the solution can do, it's important to see very quickly what STEAG is, where we are coming from, and what our strong points are. So, 2 slides only. The last numbers that I found here are from 2020. There was 2,000 million in sales. There were more than 7 gigawatts of installed capacity of energy generation around the globe, and more than 6,000 colleagues. Sometimes people are surprised. Yeah, they just know some departments from us, but they don't know the STEAG in total. And so that's even our headquarters. So having a digital meeting is nice. If you are close to Essen, give me a chat information and we can maybe meet for lunch or dinner at some point. Would be great to see you. So I belong to the subsidiary, the Department of Energy Services. Sorry, too much going on in my head here right now. So what is about STEAG Energy Services here? What makes it the best in class and what makes it so successful? Well, we always focus on the comprehensive flexibility, on the dedicated focus on quality and optimized processes. So the picture in the background is actually good. While I was still a student at Ruhr University, I was able to do an internship with STEAG, and back then, about, let's say 20 years ago, something like that, they were even talking about a solar thermal extension to existing power plants in India. That was a project back then. And so I already saw how important it was to have a holistic, comprehensive view, to really see how much of an investment is needed to achieve something. And I really liked it about STEAG, and that's why I'm still here, because it's really like the German engineering approach to all kinds of energy questions, and also about many different energy industries. So now I would like to switch our focus a little bit to the software systems and the practical challenges that are involved. And let's keep in mind, it's about the Florian example from the beginning. Somebody in the headquarters is supposed to make a decision in terms of commercial terms and in terms of technical terms. I mean, cleaning is always good. Let's say a PV collector, of course, if you clean it, that's good, but it costs money. So it's always the question of economical and technical terms. And here I would like to quickly look at 3 different approaches for a digital twin. First one is a physics-based simulation thermodynamic modeling. It's our program Epsilon Professional, for example, which I know that many of you participating today already know and use and maybe even love. Of course, if you spend the effort, if you do your homework, you make a physical model that is very highly accurate, you have proven results, you know exactly what you've done there, you have the possibility to do additional analysis for the future. On the downside, it takes a lot of effort. You need know-how of what you're doing there. So that is pretty good for everything with the water steam cycle, for gas-fired power plants, for gas turbines, and so on. That's really strong. And also it can be used for different industries there, where it's just using those very sophisticated capabilities for new challenges. The second one shown in yellow, that would be the supervised deep learning or high quality KPI, where somebody is just using the data that we, for example, took from the wind farm in the beginning, and you just choose what is important. Let's make an example quickly. Let's say with your car, you want to know if your consumption of the gas is okay or something is wrong. And of course, you would all ask a couple of questions there. Is it summer or winter right now? So temperature is important. Am I going in the mountains or out of the mountains? So you know all that. But if you put that knowledge before, you make a key performance indicator that is considering all of that, and then you get an alarm, like something is happening here. Then you know maybe your oil change is due. Maybe you know that your tires are running flat and so on, because all that knowledge is always considered and it makes your life much, much easier. So that's a very strong tool. It gives early and extremely reliable alarms. It can predict anomalies early on, and we talk about 6 or 8 weeks in advance, and it can forecast trends. And if you need to dig down, the root cause analysis is pretty easy, since everything is already there for you on the table. Downside, it is pretty time consuming. It needs technical expertise, and you have to focus. And in power plant, easily you talk about 1,000 measurements. And if you just choose a handful, 50 measurements that you really want to look at, you're losing others. And so it was always nice to have a tool there in addition that could also look at everything at once. And that's the third option there in blue, the unsupervised learning. which is, it's really nice. You just connect the interface if you have the data available to you. Yeah? If the wind turbine is really far away and you have no connection, you cannot use such an approach out of the box. But yeah, you just put in all the measurements, and the system would set up automatically a learning process. It will learn what is good, what is bad. We will see in a minute how that looks. You need limited domain knowledge, yeah, so you can use it for wind, for PV, for something else without lots of effort there. But of course, the alarm clarity is lower compared to the supervised learning. There's not a significance checking out of the box coming with that. And if you find something, then the root cause analysis is more time consuming than with the other approach here. So let's look at an example together. Data sources and edge devices. Yeah, because the example is built on getting the data somewhere. And that is just one example from the projects that I've dealt with in the past, with the customers I've dealt with in the last years. So that should show us a diverse fleet of a couple of power plants, a couple of wind turbines, a couple of PV assets, even waste to energy, gas, everything is here. And we see the big ones, they are typically connected with a strong internet connection. Maybe we're using OSIsoft Pi, something like that, to get all the data to the headquarters. With the newer assets, wind, PV somewhere, you might need an edge device. I took a picture here from our subsidiary Optenda. So that will make sure for you to collect the data on site, format it in the right way, and put it on the cell phone connection, for example, to make sure that goes to your headquarters and you have a full record there of the data that you chose. Maybe in a 10 or 15 minutes time frame, and then the power plant might be in a second or in a minute time frame. So there's still a diverse portfolio. This picture here is representing a portfolio of about 20 gigawatts, 36 power plant units in 4 different countries. So just to give you a feeling here, and this is then summing up to about 500 million data points to be processed in every year. So per plant. So that's a lot of data here, and so that is really a lot. Good. Let's go into more detail here. The nice thing, since the analysis is continuously, it's 24/7. So it's not just once a month, once a quarter. When you have somebody look at the data, when something goes wrong, you will always get the warning. And so what those colleagues here, Florian and Christian, did there, that is always done in the background as well. You can have extraordinary reports, which are a couple of those shown here from our WINDcenter. So when something is happening, somebody sits down for an hour or two and makes a report about that, and really provides the insights that are needed for the action. And here I took a picture for you that's representing the service record of a car. If you really record all the relevant measurement data, and if you record your measures and what you thought about that and what you did over time, maybe even your system that is, there's a ticket management system for your internal staff and for your external partner, that is so much helpful to really show everything is done, everything is in a good condition. You can sell it for a good and appropriate price, and not at a low price because you cannot show how good it is. Yeah, so that's so helpful, and I will be happy to show you more about that in afterwards, so in a future seminar. So now a little bit a look how to do that. Yes, so Florian is in our headquarters. Of course, he can have his own server there, but maybe for some other assets it doesn't make sense. So now let's look at those two options here: cloud versus a server approach, like your own server. And here, thanks to Christian Franz and Florian Dauber, I was able to use their slides. You can see the full presentation from our Energy Week last November in our gallery. I will put you the picture here, and also the link is in the chat. So just to look with a perspective here of what the cloud can do for us here in such an environment. So in terms of the Sense, our solar department there, they have a current pipeline here in many countries, Great Britain, rest of world, Italy, Czech Republic, and so on. About 5 gigawatts of PV projects going on currently. So that is where it's used and where it already can deliver value. They will also be in Munich soon for the solar fair. So if you want to talk to them directly, make sure to see them there. Of course, such a system, such colleagues have requirements there. And so a system, and the first box here is inside the platform. You need anomaly detection. That's what we looked at before. But you might also want to have weather forecast in there to see how is it going to be in the next week, in the next 10 days or something like that, to really see, well, something's not wrong but it's not right. So should I do something? Should I react? Should I spend the money on a cleaning, on an additional cleaning maybe? And this can really tell you, yeah, do it now because you have a very good week coming up soon. Or an O&M management tool, it would be great if you could use that to have the tools, the tickets sent out directly to the service provider there. So you can have a common interface. I had a similar presentation a couple of weeks ago. There was even a provider of such a box, and we already work together as a company. So it would be great to really connect that. And yeah, you don't send out a telefax. You don't call somebody, say something is wrong. It's very easy if you have all the data, if you have the service record, to take it out and send it out so everybody knows exactly what needs to be done. Of course, you need a cockpit, you need to look at the data and so on, and many more new features are also developed currently. So the second box is outside of the platform. Yeah, it's, of course, there's so much already available. Maybe from one manufacturer, you already have a system that you use that is good. Maybe you have a data historian and so on. For sure, you need to import third-party data here. And this approach makes it pretty easy. And there are interfaces, APIs, and so on. So that is what it's supposed to do. I will show you a screenshot soon, and you can see how that is looking then on a daily basis. Still, that was here the cloud approach. So you don't need your own server. And now you have two options in the box here at the bottom. Either you have STEAG, for example, to onboard your parks, so connect everything, take care of EdgeDevices, take care of whatever is needed to get the data in the system, or you might want to also go for a self-service where you create your own dashboards, where you make your own widgets and so on, and you onboard yourself there. So that is both up to the task, also up to the amount of savings that you are expected, so you don't spend money on something that you don't want to spend on, you don't want to earn later on. Here we have a first look at this cloud-based system. It's currently mainly focusing on PV projects. Of course, user interface, user experience is pretty important there. Transparency. So at the end of the day, those big numbers here are difficult to achieve, but super helpful on a daily basis. So let's pick one, for example. Here we have something with all parks CO2 avoided, 150 kilograms here, or availability, 97.6%, and so on. That's just what the customer here has in their own system. They see their sites, they see the tasks. We will see it soon. The smart alarms, yeah, not 100 or 500 alarms every day. Those 1, 2, 3, 4, 5 alarms that are really important. And so that is what the system provides here for PV right now in the first place, but also for wind pretty soon as well. So let's have a look at two examples here to get a better feeling what the system can do, because I like it on the point and not just fancy screenshots here for you. So anomaly detection to see if something is wrong. Here's an example from STEAG'S WINDcenter. So that's the same tool, the same SPC, the same supervised learning and unsupervised learning. So this program, SPC, that's doing that, we have the heat map that we saw on the one screen in the beginning. It's about 30, 40 measurements here on the left-hand side, and at the bottom, it's about a year of data. And we can see sometimes white lines, so that means there was a shutdown, there's no data, not a problem. But overall, this picture is pretty clear. Most is green, and here is something red, and red is bad. Red is an anomaly. If you click here on those KPIs, you can see them larger, and the top screen shows us a KPI view, so it's a normalized KPI. However, strong the plant is performing, the wind turbine is performing, it's normalized, and you can see a deviation. And here at the end, where the arrow goes, something is happening. Now, if we look at the raw data and the reference value that is shown here, it's maybe a little small, but I can show you on a bigger screen if we have a separate meeting at some time. So what we see here is in the dark blue, the expected value from the digital twin, and in the light blue, we see the raw measurement, so the data from the measurement. And so it's very difficult to spot if something's going wrong, and this system here is taking care of that for you 24/7, and it's really helping you there to focus your attention on something that is really wrong. So that was a wind example very quickly. We have another example from a PV plant, and I think that's even more typical. that, again, the heat map here, it's 10, 15 measurements, not all of them are plotted here. At the bottom, it's again about a year of data. And we can see many spots where something is red, something is not normal, something is wrong, but you might be able to fix it or not. But what is important here, we want to look at this one value here. It's in power, alternating current here in kilowatts. And again, on the top, the normalized KPI. And at the bottom, we have the raw value. And here is something wrong, which is manifesting here at the end. I don't have all the details here at hand right now. That's just a short overview to right now. But if you want to know more, just leave me a note and we can look at that in more detail pretty soon together. So let's finish here with a couple of additional views, how that helps you on the daily basis here. Dashboard here, smart alarms there, and predictive maintenance. So what's really needs to be done, yeah, fix it now, because next week will be a very windy week and you want to earn that money, then that's very, very helpful. And here, that's the energy week. You can find it here. Just go to the QR code or just to the link that I gave you here in the chat and look at the full presentation. It was 45 minutes, so I really had to cut a lot of details out here today. And it's also possible to have a separate meeting here together afterwards. So let's use the last 4 minutes here to sum up. It's so important to focus on the essential. Think again of Florian sitting in the office and maybe 50 or 100 assets he's looking at. And what should we do? Where should we drive? We can make one drive today, not 10, not 100. What should we do? What is wrong? So have the raw data, have some learning there, and have some decision-making support here. And that all on a continuous basis. And yeah, only the knowledge should help you there, data science and engineering excellence. Wake me up if an action is needed and tell me what I should do and when I need to act. So those things are all necessary to really help to make decisions based on that data and to really use that. 2 more views here. Now, left-hand side is focusing on PV again. That's with our partner, Vufong in Vietnam, where we look at power curve, losses, and so on. So technical and commercial motivations are often interfering, and this can all be set up and really provide the right view, the right information to act there. And the right-hand side, again, the SPC cockpit here, heat map, and so on. So, but identify and predict specific findings. So what's really wrong? And that's also very nice. UL, they are a big player in the wind industry. They certified our setup here because there are similar problems, similar assets. And when we or UL or the customer knows them, it's much more reliable and faster to have that all set up in the system. And the certification is really ensuring for new people joining it to make sure, yeah, that is really based on experience and not something some students just came up with or have never seen a wind turbine in their life. So I would like to finish with those questions that I gave myself here to what I wanted to share and share with you today. I think we discussed in detail here why it's essential to have the detailed view of the power plants, of the PV, of the wind assets with the data import. You already paid for the measurements. They are already there somewhere, but often the data is not used. And that's what I don't like, to find value in the data. That's what I like. And therefore have it as easy as possible to find what's going on there. Are there obstacles that are hindering the transfer of the data to the service technicians and how to overcome them? Yeah, we had the EdgeDevice that we looked at to have the data in the headquarters and then have a ticket, an email, something that's giving the full view to the service provider. And they have also the full knowledge. They know what tools they need and so on. So that's so important when it's not all on site. You just walk, you come back, you walk again 5 minutes. That's what I saw in the conventional power plants in the past. The distance was short compared to what we see now with decentralized energy production. Yeah, and the last question there, the service record, the full service record. If you think about what cell phones you had over the last 10, 15 years, what computers you had, what kind of improvement there was. Now let's think about a wind turbine that comes with a SCADA, with a control system of today, and let's look at the future 20 years from now. I'm not sure that everybody will have their recorded data at hand all the time, that they know the value that they have there. And so that is really something to think about now. If you want to sell it in 15 years, you want a good price in 15 years, then you right now should have the service history and be able to show to everybody that you've done your homework, it's in good condition, and somebody will have lots of fun with it for the next 5 or 10 years of service life. So those were the questions. I hope that was a nice ride for you to look at this from the perspective of really the people doing the work, like Florian, looking at the data, deciding where to go, what kind of tickets to open. If you have questions, leave me a note in the chat or just reach out afterwards here. And now I would like to finish. I would like to go over to the breakout room. I hope you liked it, and I hope to see you soon. We will publish new webinars pretty soon, also LinkedIn and an email for you if you registered today. And I might be accompanied by some of my colleagues there as well. So let me know what you really want to see most, and we will find the right colleagues here to join me in the future. So thank you. And now let's go to the breakout room. First room, I will share the link again so you don't have to find it. Copy link to everybody. Yes. So let's hope it works. And thank you for joining. See you soon. Bye-bye.